Thank you everyone for joining us to the last seminar of the Search and Matching Macro Finance virtual seminar series. This is our last talk of the spring semester, and we're very happy here to have Guido Menzio presenting Markups, a Search-Theoretic perspective, plus efficient and perfect competition. That's nice, Guido. Please take over.
All right. Thank you so much for having me. It's I hear my echo. For some reason. Oh, great. I don't hear my echo anymore. Yeah. So I decided I'll present you a paper and a half because this audience is up to speed. And let me mention, this is you're not the ideal audience for this paper. This paper is really meant to be taking the stuff that we do onto macroeconomists that approach things in a different way and tell them we're here and we matter. Okay, so think about it from that perspective. Here is my motivation. If you think about the standard approach to modeling market power in macro, the first thing that comes to mind is the monopolistic competition framework of Dixit and Stiglitz. The idea is very simple. In Dixit and Stiglitz, sellers have market power because they produce goods that are imperfect substitutes. The extent of market power and accordingly the magnitude of markups depend on the extent to which goods are substitutable. Less substitutable goods, bigger markups, more substitutable goods, smaller markups. And the applications in macro of this Dixit-Stiglitz approach are everywhere. It starts with sticky price literature. Here I put Dotsy, King, and Wallman, and Golozov, and Lucas, but obviously I could go back to Sheshinsky and Weiss. The literature on misallocation and cost of markup, Klina and Shea, Bakai Fari, Edmond, Midrigan, and Zhu. And the enormous literature in international trade and the benefits of international trade, starting with the work of Krugman in the 79 paper, 1980, Melitz, and there is too many to mention. Now, there is another way of modeling market power, which is what we typically do. And our approach is to think that is to follow the imperfect competition, use the imperfect competition framework of Butters, 1977, coincidentally the same year as Dixit and Stiglitz, Varian, 1980, Burdett and Judd, 1983. I'm just going to refer to this framework as Burdett and Judd because Ken is a co-author and a friend, and so why not? And the mechanism is quite different here. In the imperfect competition framework of Burdett and Judd, sellers have market power because owing to search frictions, buyers cannot just trade from any seller in the market they want. They can only trade from a discrete subset of them. And the extent of market power of sellers, the size of markups they can charge, depend on the distribution of the size of buyers' choices. Now, these models, the natural application and the reason they were sort of became popular early on is they provide an explanation for the failure of the law of one price. That's what, you know, Butters, Burdett and Judd, and Varian's papers are all about. And price dispersion is being traditionally the first kind of application. But they're really models of imperfect competition, and as such, they've been recently used for other things too. Alan Head, Lucy Liu, myself and Randy, me and Ken Burdett did some work on sticky prices using this framework. Christoph, who I see somewhere in the audience, did some early work on using the framework to understand the difference between consumption and expenditure. Sangani, Nord, and so on and so forth. Okay, so the question in this paper is, does the model of market power matter? And to answer that question, I'm going to sort of build a very simple general equilibrium version of the Burdett-Judd framework of imperfect competition, characterize the equilibrium distribution of markups across sellers, and the relationship between markups and firm size, which you may wonder, why am I doing this? This is because it's an important object in the macro literature that uses Dixit and Stiglitz. I'm going to characterize the equilibrium entry of firms. I'm going to characterize the welfare properties of equilibrium, and I'm going to study optimal policy. And I'm going to make two claims. First, I'm going to claim that Burdett-Judd framework can reproduce the properties of markups, in particular the relationship between markups and firm size that we see in the data. So Burdett and Judd provides a satisfactory theory of the markups we see. Now, you can rationalize the same data, the same things that we see, using Dixit and Stiglitz. So there is a sense in which the two models are observationally equivalent, but comparative statics, welfare, optimal policy are very different. So the answer to the question at the top of the slide, does the way in which we model market power matter? The answer is yes. And I'm gonna, throughout, try to argue that not only it matters, but in a sense, the model that we use, the model that we like, this search-theoretic model of imperfect competition, is a way more natural way approach to modeling imperfect competition than Dixit-Stiglitz is. Okay, here is the model. I'm going to be thinking is the static model is very simple. Think of a continuum of household with measure B per search good, and there's going to be a continuum of search goods of measure 1. Every household has preferences described by, let me see if I can do this, described by this utility function. Oh, geez, wait a second. Yes, by this utility function, u of y comma z. Z is consumption of a numeraire good. Yi is either 0 or 1, and is consumption of search good I, of which there is a continuum between 0 and 1. And little u is a parameter that describes the utility of consuming a unit of the search good relative to the utility of consuming the numeraire good. Every household is endowed with h units of the numeraire good and with ownership of the food. Okay? So this is the side of the households. Easy peasy. Okay. I got some firms. In the market, for every search good, there's going to be a continuum of firms with a measure determined by free entry. A firm pays a cost, zeta, in units of the numeraire good to enter the market for a search good. The firm is going to draw, after entering the market, a marginal cost C from a cumulative distribution function phi, which is a twice differentiable, nice looking CDF that has support between over the interval CLCH. The firm is going to enjoy a profit Q times P minus C if it sells the quantity Q at the price P, where C is the constant marginal cost of production. Okay, so we have seen the household, we have seen the firms, and let's see how they interact in the search market. The search market is modeled as in Burdett and Judd. Indeed, it's modeled like in Butters. every firm is going to post a price P for its good, where P is expressed in the numeraire good. Households are going to come into contact with N firms in the market for a search good, where N is distributed as a Poisson with coefficient lambda S, where S is the measure of firms in the market, an endogenous object, and lambda is an exogenous parameter, strictly positive. So that now if you know about Poissons, a Poisson with coefficient lambda S, that means that the average number of contacts by a household is lambda S firms. Now, these firms are all selling the same search good. They're selling it at different prices potentially. So they're selling perfect substitutable goods. The household is going to observe the price posted by each one of the contacted firms, and is going to choose whether and where to buy a unit of the good. And that's the end of the environment. It's a static model. Now I'm going to characterize the equilibrium of this model. Let me start, obviously, by characterizing the pricing problem of the firm. So I'm thinking about a firm with some marginal cost C that is choosing to post a price P for its product. And the profit of this firm is something that I'm going to denote as VP, C. What's that profit? Well, it's the quantity sold by the firm, which is this term in square bracket. You can call it Q as a function of P, multiplied by the profit margin P minus C. Now I want to unpack the quantity Q of P. The firm is going to meet a measure Bn of buyers of households who are in contact with N other sellers of the same good. This measure Bn is given by the formula here. It's an easy formula. B over S is the measure of buyers per seller. The second term, the second fraction here, is the probability that a household comes into contact with N plus 1 sellers, the firm we're talking about, and N additional sellers. And the last term, N plus 1, is the fact that each one of these households is contacting N plus 1 sellers in the market, and so it shows up N plus 1 times in meetings. The probability that the firm trades with one of these households, Bn, is omega NP. That probability is the sum of the probability of two events. The first event is that the household and other contacts are N sellers, all charging a price strictly greater than the price of the firm P. That event happens with probability 1 minus f of P to the power of N, where f of P, as usual, is the CDF of prices posted by firms. The second event is the following. The household is in contact with N minus J sellers who are charging a price strictly greater than P, and with J sellers who are charging a price exactly equal to P, the price of the firms we're interested in. In this case, so the probability that N minus J of the contacts of the household charge a price strictly greater than P is 1 minus f of P to the power of N minus J. Denote with psi chi of P the measure of firms, measure of sellers that are charging a price exactly equal to P. Then the probability that J of the N contacts of the households are charging exactly a price equal to P is chi to the power of j. When we are in this event, the household is indifferent between purchasing from the firm and j other competitors. And the household is going to randomize in favor of the firm with probability 1 over j plus 1. Now I have to do all of the combinatorics to take care of all the possible events. And this summation here is the total probability of this second event. Great. Now, having written what the value function, what the profit function for the firm is, it's fairly easy to do some characterization steps that follow closely the work of Burdett and Judd. The first step is establishing that the distribution of sellers over prices F does not have any mass points. This is standard for you. You all know this, but I want to repeat it for you because I wanted you to think about it in a slightly different way from usual. So the first part of the proof of this lemma is to notice the following. A firm faces a strictly positive demand even when it charges a price equal to the buyer's valuation U. And the reason it Q of U, the quantity, the demand facing the firm at a price U is strictly positive, is that given this Poisson distribution of meetings for households, the firm is always going to meet some suckers in the market. A positive measure of suckers. These suckers are willing to purchase the good of the firm at a price, at any price smaller or equal to U, including U. So QU is positive, means that the firm, by posting a price equal to U, can guarantee itself strictly positive profit. If the firm can achieve strictly positive profits, its maximized profits, V star of C, are also strictly positive, which means that no firm finds it optimal to charge a price that is either smaller or equal than its marginal cost, in which case its profits would be equal to 0 or strictly negative, or a price strictly greater than the buyer's valuation U for the good, in which case its profits would be equal to 0 because demand would be equal to 0. And you apply this argument to all of the firm's types C, and you reach the conclusion that there cannot be any mass points at any P0 that is smaller or equal to CL, the lowest marginal cost of firms, or greater or equal than U. Let me just mention this. The key step in this part of the proof is acknowledging that the firm will meet some suckers in the market. The second part of
Guido, hi, it's
yes.
Saki.
Yes, Saki.
That's an observation, right? It's not the full proof. It's like one observation that provided other, I guess, other conditions give you the full proof, right? This just says that the guy with a marginal cost will not price at the marginal cost or at the reservation value, but it could be that guys with higher cost, or sorry, with lower cost, concentrate their prices at CL.
No,
right?
nobody.
So you need extra arguments.
No, nobody will want to price at CL. Because if you have a cost, if you're the best firm in the market, your marginal cost is CL, you want to price strictly higher than CL. And if you are even higher cost than that,
yes,
you'll definitely don't want to price at CL. So
okay, so you need both are combine that one with the thing you just answered.
Yes.
Okay.
Okay. Now the second part is the standard part in the Burdett-Judd arguments. Now, suppose there is a mass point at some price P0 in between CL and U. And denote as C0 one of the firms that chooses to post this mass point price P0. And now let me try to do this. Okay. So I want you to think about price on the horizontal axis and demand. I want you to plot in your head, in fact, look at the plot of the demand curve facing a firm when there is a mass point price at P0. The demand curve is going to look like this. It's going to be downward sloping up to P0. Then at P0, there's going to be a discontinuity in demand, a downward discontinuity, and then the demand curve is going to look like that. And at P0, we are at the lower point in the lower branch already. Okay? So that's how the demand curve is going to look like for a firm. And the logic is very simple. Imagine a firm charging the mass point price of P0. Well, that firm is going to meet some household whose best outside option is purchasing from another firm also charging the price P0. These households are going to randomize between the firm and the outside option. But now think about the firm, our firm of interest, posting a price slightly lower than P0. In fact, any price is strictly lower than P0. The firm is going to meet the same type of buyers whose best outside option is another seller charging the price P0. But if the firm of interest is charging slightly less than P0, these houses are not going to randomize anymore. They're all gonna go to the firm of interest with probability 1. And that's generated discontinuity. And if you think about profit maximization when you're facing this kind of demand curve, you know profit will never be maximized there. If that price P0 cannot be profit maximizing for an individual firm, it surely as hell cannot be a mass point of the equilibrium price distribution. And that is the proof of the second part, standard stuff. But notice, if the first part of the proof used the fact that a firm always meets some suckers, the second part of the proof always uses the fact that the firm meets some buyers who have some alternative in the market. They can purchase somewhere else, whatever. Now, given the fact that the price distribution cannot have any mass points, so f of p doesn't have any mass point, that means that this fraction of firms charging a price exactly equal to p is 0 for every price p. That allows me to rewrite the profit function of the firm setting chi of p to 0. It gives me this expression where you see I've explicitly folded in b of n and omega of n of p. You can do some collecting of terms. You can calculate some infinite sums, and you get a very simple expression for the profits of a firm. And in particular, you get a very simple expression for the demand curve facing a firm. Is simply b e to the minus lambda s times f of p. The demand curve in this model, as we all know, is an endogenous object that depends, well, in this case, it's going to depend on how many sellers S enter the market, and then on the distribution of sellers over prices as described by the f of p function.
Hey Guido, this is Randy. Can I ask a question?
Yeah,
What if you didn't have constant marginal cost, or as an extreme case, you had capacity constraints, like in direct and search?
yeah, then it's much more complicated. So it's a paper that I've done and that you've seen. If you put decreasing returns to scale in the production function, so make C a function of Q, a strictly increasing function of Q, then the structure of equilibrium changes. And in particular, if search frictions are low enough, meaning lambda S is a number big enough, then you're going to have a single price equilibrium. But that's taking us to a big tangent. So let me just stop there.
Guido, and the same answer applies to whether customers buy non-zero one. So if you had you could pick the quantity. So if you had curvature in the utility.
No, because you still have, the firm is still constant returns to scale, but now it faces a downward sloping demand curve, not only because of what I have in this slide, the F of P, but also because there is an intensive margin for every buyer that is going to depend on the price. So Randy and I did this version in our sticky price paper. Okay, where am I? Great. Second part, second result again is straight up from Burdett and Judd. The support of the F distribution is got to be an interval, call it PLPH, and the highest price charged by sellers is the buyer's valuation U. And the proof, again, I want to show it to you just as a picture. If I find an eraser, is this an eraser? Yeah. Okay, think about the demand curve facing a seller. Suppose there is a gap in the F distribution between two prices, P0 and P1. The demand curve is going to look like this, downward sloping, and then between P0 and P1, there are no firms. So you can post any price in that interval. The fraction of households that you win and that you lose doesn't change at all. Which means the demand curve you're facing is straight line, and then it comes down again. Oh, geez. Imagine your profit maximizing firm facing this demand curve. This is never maximizing your profits. So P0 cannot be on the support of the F distribution. By continuity, no price to the left of P0 can be on the support of the price distribution. I cannot have a gap. Any gap is going to get sucked away like a vacuum cleaner. Similar reasoning explains why you cannot have, the highest price has to be the buyer's valuation. If you're the worst seller in town, you're only selling to captive buyers, those suckers who can only buy from you or nobody else. Those suckers are willing to buy at any price smaller or equal than you. So might as well charge them you. Standard logic. The next part is a little bit less standard. So it's worth paying a modicum of attention on this part. So I'm going to show the following. I'm going to show that the price posted by a firm is a strictly increasing function, call it PC, of the seller's marginal cost C. There are 3 bits of information in the statement of the lemma. The price is increasing in the cost. The price is strictly increasing in the cost, and the price is a function of the cost. Let's do weak monotonicity first. Suppose that P0 is one of the prices posted by a seller with marginal cost C0. And suppose that P1 is one of the prices posted by a seller with marginal cost C1 greater than C0. Now, just use revealed preferences. You can show that P1 better be greater or equal than P0, so you have weak monotonicity. Okay, this is a straight application of revealed preferences. Now, I want you to think about a seller with a cost C between C0 and C1. Now, any seller with a cost between C0 and C1 by weak monotonicity must be posting a price greater or equal than P0. Each one of these sellers, again, by weak monotonicity, has to be posting a price weakly smaller than P1. If P1 were equal to P0, then there would be a mass of firms, all of the firms with a cost between C0 and C1, all posting the same price. F would have a mass point. But that contradicts my first lemma, which means that P1 has to be strictly greater than P0. So now I have strict monotonicity of the relationship between cost and firm's price. And finally, I have to prove that the relationship between cost and price is a function and not a correspondence. So suppose on the way to a contradiction that sellers with a marginal cost C0 post some interval of prices. One of them is P0 low, and another one of them is P0 high. Every firm with a cost strictly smaller than C0, by strict monotonicity, must be posting a price strictly smaller than P0 low. Every firm with a marginal cost C strictly greater than C0, by strict monotonicity, must be posting a price strictly greater than P0 high. Okay, but that means that the F distribution is going to have a gap on its support between these two prices, P0 low and P0 high, which contradicts my second lemma, which means that P0 low and P0 high must be the same, which means that prices are a function of sellers' costs. Great. Now,
sorry, Guido, very
yeah.
quick. That's me, Christoph. Very quick question about lemma 3. Yeah, so it's super similar to Burnett-Mortensen with heterogeneous productivity. Yeah, the logic is the same. Yeah, that in Burnett-Mortensen you have that more productive firms set higher wages, and here more productive firms set lower prices. Yeah, and sorting is exactly the same. Yeah,
Absolutely. Yeah.
Okay. Yeah. So.
Okay. Now I know there is a function relating a seller's cost to its price. Now, any point on this function must be satisfied the first order condition of the firm's profit maximization problem. So for any C, P of C must be such that for a firm with marginal cost C, the marginal cost of increasing its price, which is the left-hand side of this equation, which is equal to the decline in quantity sold multiplied by the profit margin, must be equal to the marginal benefit of charging a slightly higher price. The marginal benefit is just an extra dollar of revenue for every inframarginal unit of output that you sell. That's simply equal to the quantity sold by the seller. Okay? So this has to hold everywhere along the PC function. Now, since the pricing function PC is strictly increasing in C, it has to be the case that the fraction of sellers who charge a price smaller or equal than PC, F of PC, must be equal to the fraction of sellers who have a marginal cost smaller or equal than C, which is an exogenous object, phi of C. Differentiate through by C, you get this expression. You combine the first order condition with the measure preserving condition, and you get this necessary condition that has to hold for every equilibrium PC. Now, not only this condition has to hold, I also know something else. I also know that the pricing function is strictly increasing in the seller's cost. I know that the highest price posted by a seller must be equal to the buyer's valuation U. Therefore, I know that the price posted by the least efficient seller, a seller with marginal cost CH, must be equal to U. And now if I stare at these two things, I have an ordinary differential equation for the price. This ordinary differential equation for the price together with a boundary condition admits only one solution, and the solution satisfies the second order condition of the firm's problem. So that characterizes the equilibrium pricing structure of firms. I could solve for this differential equation in the form in which it is written. Maybe I could, I don't know. But it turns out to
Guido, can you
yes.
remind us what S is? Sorry.
What
S, the variable S next to lambda.
is how many sellers are in the market.
Okay, it's the ratio. Okay.
Okay. So now I want to do this. Instead of solving for the P of C differential equation, I'm going to transform that differential equation into a differential equation for the markup mu charged by a firm at the X quantile of the cost distribution. What do I mean by that? I mean, think about the F fee distribution. That's the distribution of marginal cost over sellers. A firm at the X quantile of that cost distribution has a marginal cost C of X, implicitly defined by this equation. And now I want to compute the markup mu of X of that firm. That is, I want to compute the price of that firm divided by its marginal cost C of X. And I can write that as a differential equation with respect to mu. This is the differential equation. This is the boundary condition. And it turns out I can solve this thing in closed form down here. I'm going to talk about this formula in a little bit. But for now, let me say the following. The markup charged by a firm at the X quantile of the cost distribution is something. It is something that depends on lambda S, which is the average number of contacts that a household has. Is the average size of choice sets of buyers in the market. As you let S, as you let lambda S, therefore S, if you let that S go to 0, choice sets are getting smaller and smaller and smaller. And the markups are converging to U over C of X, the monopoly markup. You let S get bigger, go to infinity, lambda S, the average choice set of buyers, gets larger and larger and goes to infinity. Markups converge to 1, the perfectly competitive markup. As I move S from 0 to infinity, markups monotonically go down. Very simple economics, very different from the economics of Dixit and Stiglitz. You put in more firms into the market, the choice sets of buyers get bigger, there is more competition for buyers, firms are induced to lower their markups. That's how the economics of this model works. And you can spend everything going from pure monopoly to perfect competition as you change the number of firms in the market from 0 to infinity. Now let me turn to the entry problem of firms.
Guido,
I have
can I ask you? Go ahead, Randy.
Okay, I shall. Thank you. So remind us what is different from Burdett-Judd in the assumptions and the results, because a lot of the things you're saying sound like the original Burdett-Judd model. This is obviously more complicated. So what's the difference in the environment that makes a difference for the results?
It's just more general. Well, see, okay, let me tell you a few things. First, the structure, the meeting structure. The original Burdett-Judd is either, 1 or 2, and here it's the structure is described by these Poisson contacts.
Sure.
That simplifies quite a bit the algebra. Nothing of the substance.
Mortensen did a version like that, as you may recall, with Poisson number of meetings. I guess it's the heterogeneity. You're putting some structure on the heterogeneity, which.
Wait, but we're still far away from the results. So
Okay.
I'm just setting up. So let me push ahead.
Okay.
Now I want to think about entry of firms.
Guido,
So
can I just ask you one thing before you go ahead?
Yeah.
Just as a food for thought, because every time I presented this type of models to folks that are into the Dixit-Stiglitz, like the usual pushback is, well, you rely a lot on the homogeneity of goods here, right? So, but I would imagine that a lot of the results that you presented, at least if you have just some degree of differentiation, let's say you have 2 types of goods and there's a share of people that prefer one good to the other, but the rationale of competition that Burdett and Judd gives you should still give you the same results.
Absolutely.
So,
I want to make a different point though down the road if I get there. So let me move on to the entry problem of firm. I want you to consider the profit for a firm that draws the highest cost of production C of H. Okay, I know what the firm is doing. The firm is going to charge a price equal to the buyer's valuation U, and is only going to sell to captive buyers, of which there is B lambda e to the minus lambda S. And that's the maximized profit for the firm that has the highest marginal cost. Now I want to think about the maximized profit V star of C for a firm that draws a generic marginal cost C. Now I can write that maximized profit as the maximized profit of a firm with the highest cost CH minus the integral from C to CH of the derivative of the maximized profit function V star. Now, by envelope, the derivative of the maximized profit with respect to the cost is just equal to the quantity sold by a seller with marginal cost C. It doesn't depend on the price anymore. It doesn't depend on the price distribution F. It only depends on this exogenous distribution of firms over sellers, phi of C. Now I can compute the expected value to a firm from entering the market, that is the expected profit of a firm before drawing its cost C, do a little bit of integration by parts, and I get this formula. Now, I want you to stare at this formula for a second. If you think about it, these are the expected profits from entering. They depend on how many firms S enter in the market. For S going to 0, the profit of the firm converges to the monopoly profit, U minus CH times captive buyers, B lambda. For S going to infinity, the expected profit goes to 0. And as S goes from 0 to infinity, expected profits move monotonically down. Again, the economics is very simple and very different from Dixit and Stiglitz. You throw more firms into the market, the buyer's choice sets get bigger, there is more ex-post competition between firms, so markups are going down, profits are going down. Now, notice that I'm now in the position to write down the free entry condition of firms, which is this. On the left-hand side, I have the cost of entering the market, zeta. On the right-hand side, I have the benefit of entering the market, the object I just computed. The left-hand side is independent of S. The right-hand side is strictly decreasing in S and converges to 0 as S goes to infinity. There exists one and only one S that satisfies the free entry condition, which leads me to the following characterization result. An equilibrium exists as unique, and you can solve the equilibrium in two parts. The free entry condition pins down uniquely the measure of sellers entering the market for any search goods. Given that you solve for the first part of the equilibrium and you find S, you can use the formula for markups to find out what the markups are. Great. Now, let me characterize that equilibrium. This little picture is just showing you entry. On the left-hand side, I have, this horizontal line is the cost of entry. The dashed line is the benefit of entry, which is strictly decreasing in S and goes to 0. Find the intersection, you got yourself the measure of firms in the market. Once you have S, you go to the formula for markups, and you can calculate markups for every firm. Now, in this expression, I want to talk about it more. This is the formula for markup, charged by a firm at the X quantile of the cost distribution. And this markup is given by three terms. The first term here is the monopoly markup. Is the markup that the firm would charge if it was the only firm in town. It's the buyer's valuation divided by the firm's marginal cost. The second term is a discount factor that applies to the monopoly markup, and that discount factor that depends on X, the firm's ranking in the cost distribution. So if you're the worst firm in the market, you are the quantile 1 of the cost distribution, then the discount factor is equal to 1. You don't discount the monopoly markup, you charge the monopoly markup. If your X is smaller than 1, you're not at the quantile 1 of the cost distribution, then this discount factor is a number strictly smaller than 1, and you apply a discount to the monopoly markup. How big is the discount? Well, that depends, or in fact, how quickly the discount shrinks as you move down the quantiles depends on the lambda S, the average size of buyers' choice sets. If buyers have large choice sets, this discount factor goes to 0 very rapidly. If lambda S is a small number, this discount factor remains elevated as I go from X equal to 1 to X equal to 0. The last term in this markup expression has to do with heterogeneity and only show up when firms have heterogeneous markups. The intuition is simple. It says that compared to a case in which all sellers have the same marginal cost, the fact that there is heterogeneity implies that sellers that are ranked higher in the cost distribution than firm at the X quantile are less efficient at producing, and for that reason put less competitive pressure on the firm at the X quantile, which allowed that firm to charge higher markups than it would in a world where all sellers had the same marginal cost. Now, this is the main content of the paper, this formula, because it gives you an exact expression, a general expression for markups, for the distribution of markups in the population of firms. Now, what are the properties of the markups that we can get from this, infer from this formula? Well, the first thing that we learn is that markups are positive. And markups are positive even though all the varieties sold by sellers in this market are perfect substitutes. The second thing that we learn from this formula is that markups are generally heterogeneous across firms, even when firms use exactly the same technology. And the reason why markups are heterogeneous, even when firms have the same technology, is that even when all the firms are the same, equilibrium wants price dispersion. And if it wants price dispersion among firms that have the same cost, it wants markup heterogeneity. The third thing where we learn is that mu of x is generally a non-constant function, which means that markups generally depend on firm size, even though the elasticity of substitution between the goods sold by one seller and the goods sold by other seller in the same market doesn't vary with the quantity of the seller's good that is purchased by buyers. The elasticity of substitution is always infinite, and yet, in general, markups do depend on firm size. I want to elaborate on this last point. Let me go back to my differential equation for the markup, this mu of x thing. I'm going to construct the following object. I'm going to construct the null Klein mu n of x associated with the differential equation. The null Klein is the pair of x's, position of the seller in the quantile distribution, and mu, markup charged by the seller, such that the solution of the differential equation is mu prime of x equals 0. Okay? Standard definition of null Klein. Here I'm going to show you a picture studying that dynamical system. The dashed line is the null Klein. I drew it to be downward sloping, which happens to be the case when c prime of x over c of x is a decreasing function of x. So that's the null Klein. Everywhere above the null Klein, the solution of the dynamical system is going up. Everywhere below the null Klein, the solution of the dynamical system is going down. U over CH, that's the boundary condition of the dynamical system. And I'm going to draw it in this picture to be below the null Klein. I know that the solution of the dynamical system has to arrive at the boundary condition. And in this picture, it arrives at the boundary condition in the region where the solution of the dynamical system is going down. So now go backwards, go backwards, go backwards. Notice that the solution of the dynamical system can never cross the null Klein, which means that for every x between 0 and 1, mu of x, in this case, is going to be strictly decreasing in x. Now, what does that mean? It means that for firms that have high x, these firms have high cost. They charge a high price. They sell low quantity. These firms are small. They have a small markup. Firms that have a low x, they have low marginal cost. They charge a low price. They sell a big quantity. They are big and they have high markups. Bigger firms have bigger markups. This is what people in the trade literature refer to as Marshall's second law of demand. It's not coming from the structure of preferences. It's coming from the structure of competition in the Bardejjad market. Of course, this is just an example. I could draw this thing in a different way. In this example here, I have an upward sloping null Klein. That happens when c prime of x over c of x is strictly increasing. And the null Klein lies below the boundary condition u over ch. In this case, it's easy to understand that the solution of the differential equation is a mu of x that is strictly increasing in x, which means that big firms here have a lower markup than small firms. That's the opposite of Marshall's second law of demand. We could call it Marshall's third law of demand. But in fact, I can get anything. Give me any twice continuously differentiable markup function mu star of x relating firm size to markups. I can always find a cost distribution as expressed by the quantile function c of x that rationalizes as an equilibrium that mu star of x. And the formula is right here. I can get any pattern that you see in the data relating firm size to markups. I can rationalize it in the model. With a model that has none of the features of Dixit and Stiglitz. In particular, imagine that you take the data that I can rationalize with Burdett and Judd through that cost function, and you interpret it through Dixit and Stiglitz. What are you going to say? Well, you see that markups are positive. The first thing that you're going to tell me is buyers perceive varieties as imperfect substitutes. The variety of every seller is a differentiated product, and the size of the markups is telling you how different they are. Then this mu of x that you see in the data may be such that, like in reality, large firms have bigger markups. Well, then you're going to conclude that the elasticity of substitution between a seller's variety and the other varieties is decreasing in the quantity of that seller's variety that buyers consume. The more you consume of a variety, the less substitutable it becomes compared to other varieties. That's how Dixit and Stiglitz rationalize Marshall's second law of demand, by shaping the utility function. You can do that. It's fine. You're going to explain the same facts. The problem is, once you construct these reduced form Dixit-Stiglitz preferences, assuming for a second that the data generating model is indeed the Burdett-Judd model, well, you're going to say that you're going to recover the wrong preferences. You're going to recover made-up preferences, reduced form preferences that have inside, and in fact, you can do this exercise formally, these preferences are going to have inside all of the parameters of the Burdett-Judd model. And now you want to do comparative statics. Well, unless you change the preferences, you're going to get invalid comparative statics. You want to do counterfactual analysis. Well, your counterfactual is going to be wrong. You want to do policy analysis, you're also going to get that wrong. I'm not sure I have time for that. That's a shame.
Can
I ask you a question? Oh.
Yeah.
So very quickly, so you say basically that with the two models, you can rationalize the same data, but the fact that the comparative statics is different makes me, kind of gives you hope that you could have a shock that allows you to distinguish them.
100%, 100% agree. Let me give you the
with one
yes.
Sorry, just let me add one thing. With one caveat that that you don't observe markup. So the comparative static, unless you
I have a comment on that. You do observe markups in the retail trade data. The markups are very well measured, and this is a model of retail if it's a model of anything. So the reason it's good data is the price, and the marginal cost is just the wholesale price. So the markups in retail are easy to measure.
Yeah, the wholesale price is a trickier business. So if you look at the trade literature, they come up with distribution of markups across firms, but they're aggregating firms that are doing very different things, so they cannot compare marginal costs. So all they have is a relationship between firm size and marginal cost. That's what they use to estimate models, to do counterfactuals, and to do optimal policy. The statement in this paper is, you give me the same data, I give you an alternative explanation of the same facts, alternative to Dixit and Stiglitz, that doesn't rely on weirdly shaped preferences, and where the economics is different and the response to shocks is different. So going back to Julia's example, you give me your favorite before and after policy change. Take Dixit-Stiglitz. Estimate the preferences that rationalize the markup distribution before the policy change. Redo the same exercise after the policy change. Do you get the same preferences? My model says you will not, because those preferences are reduced form. And a true Dixit-Stiglitz believer will tell you we should be recovering the exact same preferences. Let me just say one more thing.
Yeah. No, I want to comment on the comparison with Dixit-Stiglitz.
No, wait.
I mean, yeah.
Yeah, let me just finish so that I stay on target. I want to tell you two things. The equilibrium is efficient in my model. This is the other important difference with respect to Dixit and Stiglitz. There are two parts to the proof. The first part is fix the measure of firms in the market. Efficiency of my model, that's very simple. What does the planner want to do for efficiency given the measure of firms in the market? Well, the planner wants a household to purchase the good from the seller that has the lowest marginal cost among the seller that emits. What does equilibrium do? Equilibrium does, the household is going to buy the good from the seller that has the lowest price. But in equilibrium, the seller with the lowest price is the seller with the lowest cost. So the equilibrium delivers efficiency.
This depends on exogenous search, right? If the lambda being exogenous is crucial for this, right? Or not?
Yeah. Of course. It's very easy to make the model inefficient. It's just inefficient in a different way. Then let me finish just a second. Then I'll let you do all the comments. The second and more surprising part is that even the measure of firms in the market is efficient. And this is a little bit more subtle. And the reason why the measure of firms in the market is efficient is that it turns out, let me say it this way. Think about what the planner wants to do, calculate when he's deciding whether to add a firm into the market or not. Well, there is a cost of adding the firm. That's the same as for the, as in the decentralized equilibrium. The benefit is that if you put in a new firm in the market, that firm is gonna create some meetings with buyers. Some of the meetings will be with buyers that have no other contact. To the planner, those meetings are worth U minus C, where C is the seller's marginal cost. Some of the meetings we're going to be with buyers who are in contact with firms that are worse than the firm that I've just added in the market. Those meetings that are worth C hat minus C, where C hat is the buyer's second best option, the marginal cost of the buyer's second best option. And some meetings are going to be with buyers who are in contact with firms better than the firm that the planner has thrown into the market. Those meetings are worthless. That's the calculation that the planner makes when deciding whether to put in an extra firm or not. It turns out that the payoffs that the firm gets from entering the market are exactly equal to the social value of the meetings created by the firm.
Why is there no Menzio's condition that applies?
It's two things. It's a Hosius condition and a revenue equivalence theorem. The Hosius condition is related to the fact that the meeting function, so to speak, is lambda times S, so it's linear in firms number. No congestion. of firms.
I see.
When I throw an extra firm, it just creates additional meetings, which to me makes total sense in retail or consumer goods market. In fact, I don't even know what that curvature means in the labor market, but whatever. The second result, the second part of the proof is a revenue equivalence theorem. The fact that the price posting gain of Bardet and Judd generates revenues that are the same as an ex post auction between firms competing for a particular buyer, which are exactly these payoffs here if you look at that. Imagine a firm competing with another firm. Sorry, imagine a firm that has met a buyer and there is no other competitor. The outcome of an auction there is such that the firm is going to charge the price U and enjoy a profit U minus C. Now imagine the firm meets a buyer and that buyer is also in contact with another firm. These two firms are going to run an auction. The firm's profit is going to be the difference between the marginal cost. The firm is going to charge to the buyer a price equal to the marginal cost of the other firm. And the firm's profit is going to be C hat minus C. And if the firm meets a buyer who is in contact with somebody better, the firm is going to lose that auction and its profit is going to be zero. The surprising part is that the Bardet-Judd pricing gain is revenue equivalent to an ex post auction. Put that together with the structure of the meeting function and you get efficiency of entry. Now, why does that matter? Because, and here is the biggest point. If you read the millions of papers that every year get published on Dixit-Stiglitz in macro, they're going to make statements like this. Because markups are positive, there is inefficiently low production. Sure. They say there is a gap between price and marginal cost. You should produce more. There are welfare gains that are unexploited. So we should subsidize production. They're going to say, as long as markups are heterogeneous across firms, there is misallocation. In fact, precisely, you should subsidize more firms that have bigger markups than you subsidize firms with low markups. And in general, the entry of firm is going to be inefficient, so you're going to have to screw around with the entry margin too by taxing or subsidizing entry. None of these three conclusions that you find in paper over paper over paper are warranted based exclusively on data, on observations about markups and the heterogeneity. I can make sense of markups being positive, markups being high at big firms and small at small firms without having to introduce any inefficiency in the market, and so that no policy intervention is the optimal recommendation. The fact that you see markups tells you preciously little about whether the market is inefficient or not. And let me conclude with one picture that is a little bit, maybe is informative. I want you to think about this. So what do you do in Econ 101? You put quantity and prices, right? And you got some inverse demand curve. And you say, marginal cost, price. Ooh, there is a gap here. There's a welfare loss. You should, if you could drive the price down to marginal cost, there would be more trades taking place with positive surplus. That's why equilibrium is inefficient. And if you have firms with bigger markups than other firms, those firms need to be subsidized more so that their price goes down more. All of that is based on the presumption, which is just a presumption, that the inverse demand curve is the marginal utility of consumption. But you don't know that. Nobody knows that. I gave you a model where firms face a downward sloping demand curve, just like here. There is a gap between price and marginal cost, but this gap doesn't imply inefficiency, and shrinking that gap doesn't improve welfare, because this curve here is not the marginal utility of consumption. It's a distribution of outside options, of buyers. And these outside options are trades with other firms that are in fact more valuable than the trade that you're looking at or entertaining in this curve. Reducing the gap between P and MC, if all firms are identical, is a wash. You're just inducing buyers to purchase from one seller rather than another equivalent seller. If firms are heterogeneous and you reduce the gap between price and marginal cost at one firm, you're actually going to lower welfare, because you're going to distort the allocation of production. Of course, going back to Luca's comment before, of course I can make the model inefficient, but that's not the point of this paper. The point of this paper is to say there's a lot of sort of hardwired if-then statements that people make in macro, that if you look at the data through the lens of better than Judd, are no longer warranted. And so this is like a cautionary note to our colleagues.
Thank you very much, Guido. This was a great talk, and we can take like another 10 minutes and jump for discussion.
Of course.
So, I mean, throughout the talk, when you were making comparisons with CES, I really didn't understand what type of
Okay, let me clarify.
comparison.
I'm not
just let me clarify what I want to say before you answer to me. So if you go back to Romer, the two Romer papers, which use a CS structure, it's very different to think of entry and competition on the variety margin than through the cost margin. So I think a lot of modern macro says, okay, when there's entry in CS, it's like a new variety where you have monopoly or the variety. But there are other papers like Ivan's paper with Oliver Wang, and I think Simon Mongi's stock market paper, where it's within the variety that you can have like two firms or even a continuum of firms, and that's where you see the competition margin. So what do you have in mind?
I don't have in mind CES. I'm having in mind every model that I call Dixit-Stiglitz, like Dixit-Stiglitz 77, is a model where every seller is the unique supplier of its variety. So every seller is a monopolist. And not surprisingly, the economics of this model, of that model, are very different from a model of imperfect competition coming through search frictions. But I'm not restricting myself to CES at all. In fact, CES cannot get markups to be a function of size. Right. I have in mind all of the paper. There's, I mean, too many to mention, where they start with some utility function that is identified off of the markup size distribution. And where the assumption of the market structure is that every seller is producing a differentiated variety. So what I'm not including in this, in fact, I'm very sympathetic towards Atkinson and Burstyn, which I think is, a more sensible way of approaching competition, imperfect competition, which is, these two layers of CES, and then use you have finite, there the relationship between firm size and markups is not coming from funky shapes of the utility function. It's coming from the fact that larger firms have a different price impact on their inner CES aggregator price than smaller firms.
Got it.
Guido, I have a follow-up question on efficiency. So if I kind of see these Burdett-Judd models as ones where it's a bit of an extreme case for tractability, where the elasticity of demand with respect to price is zero.
Yes.
So if you have a little bit of a slope of demand, you're going to get a bunch of the inefficiencies from markups coming back in.
Beautiful. Totally. That's where the empirical literature should go to. So ideally, in a world, and this is not what I can do, but it's something that somebody can do. Here's what I have in mind. In general, I've got some quantity, I got some price, I got inverse demand. That slope is coming from two things. It's coming from the U prime of C effect of Dixit and Stiglitz, which is associated with inefficiencies if you have a gap between prices and marginal cost, plus these outside options. Heterogeneity, which also creates a downward slope. If somebody wants to really say something about how inefficient markets are, it's not enough to give me measure of markups, or even worse, measures of elasticity of demand. You gotta tell me how much of the downward slope is coming from the two channels, because one is welfare neutral and the other one is associated with welfare losses. So to me, that's where the empirical literature should go, but it's not easy.
So Guido, what addition? So if you just look at markups, then the two models have you can rationalize the two models giving the same result. What addition? And I think, I suppose you can still hear me even though my connection is unstable. I think what you said earlier was that the comparative statics should differ.
Yeah.
And so the question is how empirically someone else would get at that.
Yeah. So okay. One example would be, and this is stacking the things in favor of this model. But there are papers that have data on distribution of markups in before a policy change. I don't know, like changes in taxes or whatever, or some, I don't know exactly what they do. But anyway, think about a policy event. And around the policy event, you have the markups before, the markups after. Maybe opening up to trade is a good example. So a change in tariffs. Now, if the Dixit-Stiglitz model is correct, then preferences, you should recover the same preferences before and after, given that you take into account the change in policy.
Okay.
A smoking gun of the fact that you're recovering reduced form preferences would be that your preferences have changed before and after, which shouldn't happen, which doesn't, you don't change the preferences when you do your own counterfactual at the end of your paper, but I suspect they would. So that would be an example. But I think opening up to trade would be really a very clear way of disentangling the two models of imperfect competition.
Okay.
So Guido, just one question in
Yes.
terms of, so because the fundamental in your model that you need to recover is the cost distribution across firms, right?
Yes.
And you can get that through like the price distribution, correct? Because you have this one-to-one distribution. So in some sense, you could get like the Nielsen price and recoup based on that distribution, the cost distribution. So the alternative to the Dixit-Stiglitz in terms of the policy is that if there is a change in policy that doesn't affect the cost distribution, your price distribution should be the same pre and post the policy, right? So that would be a somewhat easy one to test too, right?
That's the nasty response to my suggestion of re-estimating before and after preferences in Dixit-Stiglitz would be for my model, for this model, estimate the cost distribution before and after a policy change. You should be recovering the same C of X function.
Correct.
Excellent.
And that might be easier to test.
Yeah, I don't know. I mean, marginal cost is such an abstract concept that, you know. But that's a really good observation. That would be the analog.
Right, and there is a literature that's trying to test these things, right? With like the price dispersion using the Nielsen data.
Yes, that's true. But that's not the. This is more our little fiefdom. Mainstream macro is just taking all of the firms in the US, putting them together and constructing a mu distribution out of them. And the costs are uncomparable because these firms are doing different things.
How much of the efficiency result depend on the 0-1 purchases? I think you mentioned something about potentially going.
It does. If as soon as there is a quantity choice, a price different from marginal cost is going to create a distortion there. But here's what I'm thinking between us.
Mm-hmm.
I guess this is a bit is a comment inherited from Randy. If those distortions were important, the quantity distortion was more important, you would expect to see way more two-part pricing in the real world than you actually see.
How so? I cannot reach the conclusion from the statement.
Yes, okay. So imagine you have a quantity choice in my model.
Mm.
Now, if you only can post a price, well, you're going to live with some inefficiencies. They're going to be smaller than the inefficiency you would infer from the slope of the demand curve. But there's going to be some.
Mm-hmm. Mm-hmm.
But why are firms in that world posting prices? They should extract
schedules.
Yeah, exactly. They should have two-part pricing, where there is a trading fee together with a price for an extra unit of the product that is set equal to marginal cost.
Mm-hmm. Mm-hmm.
I mean, in the world of 2025, that's not that difficult to accomplish, and yet we see very, very little of it.
Mm.
Which to me makes me suspicious that maybe intensive margin is not that important in retail.
Mm. Mm.
But guessing game here.
Certainly on many products, right? Certainly on many products. Like you don't buy, 3 pairs of the same Levi's jeans. Unless you're really stingy, right? You don't want to take advantage.
No, I mean, there may be a little bit of substitution. The price of tuna goes from $5 a can to $3 a can. I may eat tuna-based dishes once more a month, I don't know that that's very big.
Sure.
And that's me. I'm a particularly tuna elastic person.
Guido, can I ask, so is your equilibrium still efficient if you endogenize the consumer's reservation value? In, let's say, the dynamic search model, random
Nice.
search model.
I don't think so.
Okay.
Yeah. Good to see you.
Nice to see, but there could be over or under entry in a dynamic model, in a random search model.
My suspicion is that there would be excess entry.
I see.
Your reservation value would be too high compared to efficiency.
Okay.
Maybe I'm extrapolating too much my intuition. You know, I don't know.
It depends on how the market behaves, right? If you expect somebody else with a lower marginal cost to enter tomorrow, you know, that may deter you from entering.
But that's too hard. That's too hard. Keeping it simple, like it's just
So then what?
the repetition of the static model and entries at data 0.
Then why would it be different than just a static?
Because the entry
Remember,
affects
because
the
U
meeting.
becomes endogenous.
Yeah.
You can hold off to consuming your can of tuna.
Oh, with it, like, okay, I see.
Yeah, and that's gonna involve the prices that you get, but the prices that you get are not good, right? They're distorted compared to the social values, the social cost of production. So, yeah. But again, I'm not too worried about that because that's not the point I want to make. I would just tell these guys in macro that they're overreaching with their conclusions, especially the policy stuff. The policy stuff is really getting to the nitty-gritty of like the third decimal point of how to design the optimal subsidy, where you don't know whether there's an efficiency to begin with. And I just want to provide a counterexample. So because my goal is to have a counterexample, I'm not worried about robustness very much.
Why don't we take one last question to end the seminar? It's been great. So if anyone have anything? Okay, so thank you everyone. Thank all the panelists for coming, and then like this was a wonderful discussion, and thanks Guido for presenting a great paper.
Thank you so much. Looking forward to seeing you in IRL, as they say. Bye.
Thanks everyone.